There's a contradiction in the world of large-scale data at the moment. The de facto language of data science is Python. They have all the cool libraries, they have all the people pushing data crunching forwards. But the de facto language of data infrastructure is Java. They have all the big-name Apache projects for handling large-scale data in real time. And neither side really wants to become the other. There's no sign that the Python world is about to try and rewrite Kafka. And there's no sign that the Java world's going to come up with something that replaces NumPy, even though numj would be a very satisfying word to say. But until someone bites the bullet and writes numj, I think the divide between data science and data infrastructure is here to stay. And that's a very fertile ground for bridge builders. My bridge building guest this week is Tomáš Neubauer. He's the CTO of Quix, and I might summarize his bridge building technique as use Python for data science, use Kafka for data infrastructure, but if you stop thinking of Kafka as a Java tool and just think about it as a protocol, the solution is to teach Python a new protocol. But that's a lot of work. And how is it done? How do you implement a pure Python version of the Kafka world without rewriting Kafka? How much work is it? The devil is in the details. And even if you do all that work, is it enough to give people tools in a familiar language? Or are you still left with the problem of teaching them new approaches too? Let's get stuck in and find out. I'm your host, Chris Jenkins. This is Developer Voices, and today's voice is Tomáš Neubauer. Joining me today is Tomáš Neubauer. Tomáš, how are you?
I'm great, thank you. How are you doing?
I'm very well, very well. Nice to talk to someone. You're not too far from me, right? You're in London.
Well, currently I'm in Prague. I'm flying to London next week. So I'm traveling a lot between Prague and London.
That's a nice life.
When the traffic is working.
Yeah, I spent some very happy times in Prague, so maybe I should come back with you sometime.
Yeah, sure.
But we're not here to talk about international travel. That's a different podcast that I'd happily present. We're talking about the world of Python, right?
Yeah.
Python, obviously, a de facto key part of data processing in the technical world. And you've been trying to push the de facto state of things in a new direction, which we'll get to. But give me your estimation of the market as it stands. What's the normal way that people do large-scale data processing in Python?
Yeah, well, the world is quite difficult, to be honest. If you are in Python and you want to do a large data processing right now, it depends on what are your requirements, of course. If you go to batch, it's slightly better. But if you go to real time, and we're talking about building stream processing pipelines, your options are either using old big server-side processing engines like Flink or Spark Streaming. And you can also use, you can build it by yourself. So you can use Kafka and client libraries or similar brokers and their client libraries to do it by yourself. And third option would be using some cloud providers options like Lambdas, for example. But they have lots of limitations as well. Now, the reason why I'm saying that it's not ideal is because Kafka and Flink and Spark, they are all coming from JVM world. And as a result, for you as a Python developer who wants to use them, the life gets suboptimal. First of all, it's just you don't feel to be a first-class citizen in the ecosystem, and secondly, when you actually try to use it, you will see that you have to do lots of Java-related stuff.
Yeah. The first time I used the Python Flink API, I was disappointed to get a Java stack trace back.
Yes, so that's true. but I think I got disappointed even more when I had to put a jar files of Kafka connector, and then a jar file that this jar file depends on into right folder, and then and reference it in my code. I was even more disappointed.
Yeah, I hadn't thought about that because I'm used to writing in Java as well, but that's not a friendly way to treat a pure Python developer.
Yeah. That's definitely not it. And there are more problems to it. When you want to build your user-defined function in Python, which I guess this is why you're using something like Python, because you want to use Python to build a business logic or potentially use something from the Python ecosystem. And it's not that straightforward because you're actually not running your processing in Python. You're running in Java. And so what the Flink does, for example, is run to runtime on side by each other, and there is some socket connection between them. And when you map your user-defined function in Python to some columns in Flink, what's going to happen that there will be basic communication between them, and that means you can't really debug it easily. There's performance implication on if the payload is too big. And if anything gets wrong, you get an amazing Java stack trace back.
Yeah. Okay, but I think a lot of people in the data processing world recognize that problem, but very few want to bite the bullet and rewrite something of the complexity of Flink in pure Python.
Yeah, well, I think that there is a couple of new emerging server-side engines that's trying to be more friendly to Python. And there was a project called Faust, made by Robin Hood, that actually were on a direction to do something, but it got abandoned, which is a shame. And then obviously you have the cloud providers options, but then you have a quite strong vendor lock-in, and they actually have a lot of limitations. Like, I don't know, if you use AWS Lambda, you will struggle if you have a state in your services or in your transformations, and there are problems with dependencies and resource limits. So again, lots of drawbacks there.
Yeah, I can see that. It's when you have to deal with state that stream processing gets really interesting. Up to that point, you could just use simple transformers.
Yes. Well, basically, I always say that until you are limited to one message at a time processing, so when you process your data, you don't care about the message before and message after. It's a doable option to use just a client libraries of your broker or of your distributed system and do it by yourself. But the moment you touch state, I think it gets exponentially more complicated to build in a scalable and resilient fashion. It's a really hard computer science problem to solve.
Because you have to start thinking about persistence and distribution of that state.
Yes, and partitioning of your data, checkpointing of your data and state, delivery guarantees, reassignments. So there's a lot of stuff, that could happen during your state being changing. And so I would really not recommend to build your own stateful processing on top of client libraries just for the purpose of one project. It's
okay. Then, because I know that seems like very good advice, but I know that you had a project where you felt this pain and suddenly decided to build a stream processing library in Python for one project, effectively.
Yes. So
in a way, so what's the project, and why was it so painful for you that you decided to bite the bullet?
Well, so in my previous job, we were building real-time decision insights for Formula One, and there was basically a pipeline with telemetry data from the cars. And an idea was to build pipelines that would tell you what to do in next seconds, not next hours. And the amount of data was quite huge. It was around 30 million different values from different sensors per minute from each car. And the people that were developing these pipelines were, the mechanical engineers, data scientists, ML engineers. They all wanted to use Python or Java. And this is the first time I saw, well, hold on, this is very powerful technology. The streaming stack was really, really great. It worked really well. But to actually leverage it by these teams was very difficult. There was no tools, no way to simply analyze data. So, things like Kafka tool back then wasn't really sufficient enough. And then when we actually managed to explain everybody how to connect to the source of data and how to actually, get it to the Python, the biggest problem was the muscle memory of working in a batch, just analyzing data in database in Jupyter Notebook versus building real-time streaming applications where you process row by row. It's such a different paradigm, such a different approach to the problem that they struggled a lot with just the concept of streaming. And sometimes I'm saying even a mean that's the most simple operation that you can do in Excel. You have imagine you have speed, RPM, and you want to do average speed on a table. Now everybody can do that, but to do a mean in the last 10 seconds for a car, real time, it's actually a very complicated thing and very different approach to do it.
This is something that always interests me because I think a lot of this sector of the tech industry acts like it's a purely technical problem. And that's a big part of it. But the mental problem is a surprisingly large leap, right? And you almost would have thought, Python has asynchronous coroutine primitives, right? And they've been in there for a long time. You would have thought the idea of streaming data would be a little more normalized in Python.
Yeah, I think that building asynchronous code, it's obviously a bit more complicated than a single-threaded code, but I think the streaming goes much further than that. It's the level of unintuitiveness for somebody who spent the whole life working with the static data is much bigger than someone moving from single to multi-thread application. And sometimes I kind of, compare this to people trying something like reactive extensions for first time. It's such a huge, overwhelming new thing. Or when people in the past moved from a classical, WinForm style desktop applications to this MVVM and MVC patterns in a web. These big mindset switches require you to suddenly do a common task very differently, and this is very similar. Like everybody is used to get the data from database, analyze it in Jupyter Notebook, print it on a waveform, look at it on a map, maybe do some filtering, some analysis, and they are in the comfort of that the data are not moving. When you run stream processing code, every time you run it, it will get a different input, and that's just so difficult to handle because at the end, you're building something which gets input, you do something with it, and you put output. And it's difficult to tune that middle box when the inputs are changing every time you press run. That's difficult.
Yeah, I totally see that. And I mean, maybe I've been thinking in this way for too long to fully see the problem. But to me, it almost seems a lot simpler. You just have to build something that deals with one thing at a time. and some other engine will scale that up to dealing with an infinite number of things.
Yeah, so that's obviously one way of looking at it. The problem is when you get stateful, you need that context of your data. And then in streaming, where it's get even more difficult, is that a part of the actual data, what really matters is the behavior of your data. So order of messages, the speed of messages, and schema are also important not to trip over your code. So when we were back in Maclaren, for example, there were lots of bugs and crashes caused by just a nature of the burst of data coming after the start of the engine. So people just did not unit test it and could not think that there would be a burst of data in the first 5 seconds worth of 5 minutes normally. And they just got a lots of memory overflows. So the nature of the data, how they come in, is also important, not just the content of it.
Okay. Yeah, okay. So let's start talking about your solution to this problem and how you designed it. Because it's a twofold problem, right? You've not only got to design tooling, but find some way of making it... Is it a question of training people to think in a different way, or is it a question of finding a way that fits in with their current thinking?
Yeah, well, I think it's a bit of both. Having said that, I don't think that we can go away with just training people. I think I personally, by myself, felt that it's rather difficult. So, when I was looking at the streaming and how you can, what are the obstacles in learning curve? That was basically I was trying to look at, like, I haven't done the streaming at all, and now I'm in this moment that it's intuitive for you to do streaming. What are the obstacles on this journey, and can we somehow remove them? And I think that the first big obstacle is what we discussed at the beginning, which is you are not actually running your code; you're running it in the engine, which is even not Python. So I think the big power of something like Faust or something like Quick Streams library is that you actually run your functions in your IDE. So you can leverage the ecosystem of the Python, and then when you inject any sort of dependency from it, you will see how it works in your IDE, and you can debug it. You can go line by line and see, okay, I'm using this mathematical function from this science package, and it's crashing because I'm giving it badly formatted numbers. And right. I see it because I get the breakpoint before I call that library, and I investigate all the inputs, and I in a watch window in my IDE, I'm changing the input until I get it done. Yeah, now that is a vastly different experience for developer than I'm just deploying some black box, which I'm registering to my engine, and then I'm seeing crashing or not, and I'm relying on logs to
yeah. As much as I like cloud services for putting things in production, having something local and native is just much nicer for development time.
Yeah, for sure. Okay. And especially when you get into the more advanced stuff like the machine learning and computer vision, you also get dependencies issues. So you might do just pip install something like in computer vision, and it will not work until you get a particular system dependency in when you run your code.
Yeah.
And so if you have a server-side engine, you have to make sure that every node where this Flink cluster or Spark cluster runs will have this dependency, system dependency. Like for computer vision, you have the libs, something just going to have to be there, which normally you just install in Linux. Now, if you go with a microservice Docker route, you have Docker to do that for you. And that's brilliant. It's just a line of in a Docker file. So I think that library approach, where you're basically running library in containers, gives you not just a better IDE experience, but also much easier integration with this ecosystem of the language, which in this case is Python.
Okay, so in that scenario, are you connecting your IDE into the Docker container so that you're developing inside Docker?
That's a good question. Yes, it's an option. So you don't have to do it. You can obviously develop Python on your laptop, and it's very easy to do that. But what we're working right now is exactly to cover this with a dev containers. So the idea is that you have the Docker file that you'll be using to deploy your code, and then you attach it to your dev container. So you have exactly the same environment for your Visual Studio Code or PyCharm. And it's brilliant, especially when your Python library doesn't support M1, for example. So I'm using this very often because some Python libraries still not built to M1 architecture. And you can use dev containers with a different base image to overcome that.
Yeah, that makes sense. I'm just making a quick note to look up dev container support for NeoVim, and I'll move on from that because not all of us use VS Code.
Well, I'm not sure. But it's a quite a popular technology now. I would guess there will be some support. It's rather brilliant because you can even configure things like your add-ons in a dev container config file. So you can literally pre-package the environment for developer with everything they need, and so they're using it locally or in cloud.
Like all the editor plugins.
Yes,
that you want.
Yes, exactly.
Yeah, that's nice. Yeah.
So what we're working right now is that we're gonna have in our quick CLI. When you are developing Python code, you would have a command, and that would open the Visual Studio Code with everything you need to develop Python-based stream processing service, including all the requirements, all the Python stuff, all the Python plugins in your Visual Studio Code. So you don't have to go to a painful journey of learning by yourself.
Yeah. That sounds nice. But that seems like step one, right? If that were just the problem you were solving, you could have gone into the developer tooling business.
Yes.
Generally. So what's your next step from that into making streaming specifically easier?
Well, to be fair, I actually did. So the first years of Quix were more focused on tooling, which we just discussed. And the second part is quite interesting. You you kind of order it as it really happened. The second step is the actual stream processing, which is a second challenge. So even if you have a tooling, even if you get everything you can imagine to develop comfortably your code, and you have oversight of the data, and you can deploy the code easily as well, which that was a huge problem for us to teach people how to use Kubernetes so they are independent. You're either gonna build a monstrosity internally so people can use Kubernetes somehow abstracted, or you're gonna teach them how to do it. There's no ideal solution. Yeah. And then even if you give them that, then you will find that they just can't, or not can't, but it's very hard to get the head around this new concept. And so this is where the streaming data frames idea came to the place. An attempt to bring a batch muscle memory into streaming.
Right. Data frames are a term I only really know from a cursory acquaintance with pandas, right?
Yeah,
but you're treating it as more of a concept than a library-specific thing.
Yes, and to be honest, we are not the very first who had the idea to use the concept outside of the technology. So PySpark has slightly similar approach to batch and big, Spark data manipulation to give you a pandas interface to analyze your data, but actually under the hood is not pandas, but it's Spark, and the rows being redistributed in a Spark cluster. Now that's what we did with streaming. So you can think of topic in Kafka as a log of messages. Okay, you're gonna have thousands of messages in different streams. Stream being a message key. So if I give an example of a different Uber cars driving around the city, now each driver gonna send a message with the message key driver ABC, and the payload is gonna be some data, GPS location, longitude, speed, etc.
Yeah.
Now you can think of that as that each stream is actually, if you rotate it by 90 degrees, it's an infinite table, an infinite virtual table where each property of the message forming one column.
Yeah.
So imagine you have JSON. Let's simplify this for JSON. There will be a property called speed. And that property will repeat in every message of that stream of that one driver. Now, what we're doing is we basically flopping it 90 degrees to a table where each message is one row. And then you're working with that table like it will be static in your Jupyter notebook, like it materialized. But actually it didn't. So let's say that you have a speed column and you just want to, for practical reasons, convert it from meters per second to kilometers per hour.
Okay.
If you would have the static data in your Jupyter notebook, we would just do a one-liner in pandas. df, name of new column, equal df speed multiplied by 3.6.
Okay.
And it would just add a new column to your static data. Now, we do the same with this virtual table, but the difference is that every time we get the new message, which is the new row, we execute this function to add that new column, which is actually in this case new cell, and then we send it to output topic. So we are doing the same thing, it's just we're doing it for every message rather than the whole table.
Right. So I'm building up a mental image of an Excel spreadsheet where I can scroll down and down and down, and it keeps going, and new stuff's coming in even as I scroll.
Yes.
And I would like to pretend I can just transform. I can add a new column in my Excel sheet once. What you're doing is pretending, or is back forward filling that every time a new row gets added. You add in that column that I defined earlier.
Yes, exactly.
Yeah.
So when you're writing your Python code with streaming data frames, you're actually not manipulating any data. You're building a lazy loaded data pipeline, which will know what to do when the first message arrives. And then that instructions, so you're building basically instructions with your Python code. That instruction will be executed for every message. So you don't have to think about that. Your brain doesn't have to kind of absorb the fact that data are flowing and they are causing this rather unnatural behaviors compared to batch. But you can focus on the actual data and manipulation of it. So, for example, if I create a classical batch operation, I load the data of an Uber driver, I add the new column, and I put it back to database.
Yeah.
And basically what I'm doing is I load all data, I add the column once, and I save it once. What I'm doing here is that I have an input topic where I'm getting these rows as they arrive to my transformation. I'm adding the column to each row independently, and then I'm sending it to output topic where somebody gonna consume it, equal as somebody gonna consume the result of the batch work in the table. So at the end, you can sync that data pipeline to table as well. And the only difference would be that the rows would be appearing real time rather than once per day or once per hour when the batch happens. But the result is the same. And you are abstracted from, as a developer, from the drudgery of thinking in this paradigm.
Yeah, I can imagine writing some code in Python that looked like I'm doing a for loop over a list, and then some compiler magic transforming that into a bunch of yield statements, which actually are processing it one by one as it comes in, right?
Yeah, that's very similar. Yeah, it's that way of thinking, yeah.
Okay, I'm happy with that. I think this, and I could see how that would insulate the developer who's happy with batch from dealing with the streaming world. Surely this gets hard when we reintroduce things like state and windows.
Yes. Having said that, it's still, it's not 100%, obviously, because, for example, with the windows, there are more windows types in streaming that make sense in batch. Like, for example, a hopping window is a bit, intuitive in a batch board. But things like rolling windows or tumbling windows, they are still same in Jupyter Notebook or in streaming. So you can think of like, give me a last 10 seconds average speed. Now, if you go to a Jupyter Notebook, you load your driver data and you do that operation, you would do df.rolling, you put the parameters, and it would add a column which would use the values from the cells above to calculate the value. What we do instead is that as the rows are coming in, we save them to the state, and then every message coming afterwards would be a combination of the incoming message and the state to produce the output. So then we kind of moving from IO box to IO box plus state, where the logic goes with the state as well.
Okay. Let me see if I can push you further on this, because I can see how you could library away, compiler away some of the differences between streaming and batch. Does your shield not break when you start doing things like streaming joins of potentially infinite sources of data?
Yes, obviously, as further we go to a stream processing specific features, it will go far from each other. But still, for joins, you can join data in a static environment. You can join them in a streaming. In streaming, you have to provide more information to a behavior that you expect. So, for example, how long you are willing to wait for your data. Now, of course, that's not happening in static because you have the data at your disposal. Yeah. But here, you might want to be waiting 5 seconds for the second source to arrive. And that slightly complicates the things. But my thinking here is that it's a journey. You're going to stream processing, and you're going to start with simple stuff, then move to probably some stateful stuff. The joins are really hopefully the thing where you can start with some defaults and then start tweaking it. Still, I think much simpler than using just the client API.
Okay, so I think. Tell me if I'm right or wrong here, but I think I'm going to characterize your approach as lots of people in this world are trying to say we need to make it seem familiar for people. So we'll start with SQL. And that seems like a good choice. but eventually you hit a ceiling where SQL isn't powerful enough for the job, and then you get bumped into Java. And you're saying we can still do the same trick of making it seem familiar, but if we start with Python, eventually we'll have to introduce new concepts, but we won't have to introduce a whole new language.
Exactly.
Yeah.
And we carrying all the perks of a stream processing library with it, which is native in the language. So hopefully, people can debug it to get a bit more sense into it, and when they're building the logic, it will be a bit less complicated to debug the problems. So that's the idea behind it, yeah. And hopefully the muscle memory from batch will carry on into the streaming.
Yeah. Okay. Yeah, I quite like that, because it's like saying you will have to learn new things, but you don't have to learn a lot on day one to even get some results.
Yeah. And this was always our way of thinking, is to, if there is a path to get you to something where you see the value fast, people will appreciate that, because I always felt that when you have this when you're learning a new technology or new thing in general, having this anchor point, okay, I know that I can do something, and I feel enabled to do new thing because I just learned this new stuff. It kind of drives you to and motivates you to go further. When you have to spend a long time to get to the first anchor, you start you get doubtful, like, am I actually going to get there? and maybe just bail it out.
Yeah. Is it the library? Is it me? Is it time to move on either way?
Yeah, exactly.
Okay, so let's dive into some code, because I can easily think of a language or two where I'd like a decent stream processing library that isn't Java. Let me pick one. I'm going to say Gleam. I want a stream processing library in Gleam. I'm feeling spicy. Tell me how and how much work I can expect to build a proper stream processing library in a new language. Give me some pointers.
Well, basically, first thing you have to look at is what are the client libraries for the broker you want to choose. So let's say you want to use Kafka.
Mm-hmm.
Now, if that language has a decent library for that for the broker that you want to use, the one thing is Stick. It's a good start.
Okay.
And then you're gonna have to learn a lot of concepts if you want to go to stateful stream processing. For stateless, it's more about packaging the whole Kafka interface into more digestible, more language-specific interface or use case interface, if you like.
Take the Kafka library and make it idiomatic for the language.
Yes.
Yeah. Okay.
But then when you go to stateful stream processing, then it's a journey, because you need to think about how you're gonna store your state. Are you gonna use changelog topics? Are you gonna use state with checkpoints? Are you gonna duplicate your state to do some resiliency in terms of database corruption? And then you need to find a way. Am I gonna use my broker and possibly the deployment engine like Kubernetes to scale my processing, which is the client library approach? Or am I going to build a server-side engine that's going to manipulate my data and my code in a fashion to do that? They are both directions has plus and minuses, but this is the decision you have to do. And if you go with a streaming library like we did, then yes, you're gonna have to use the broker scaling and resiliency features to make this scalable and resilient. So like retention, replication factor of the topics, the assignment of your partitions. You're probably going to have to use temporary topics for certain things like group by. So the way how you can do group by with the streaming library is that you restream your data to a temporary topic, and then by that you repartition it.
Right.
If you do it with a Flink, you will basically Flink will take the data and partition it inside the engine, but we don't have the engine, so.
Yeah. So you have to build some kind of process job graph generator thing that's transparent to the end user.
Yeah, and transparent, but also extensible. So I think that whatever your built-in methods are, rich or not rich in terms of what you offer and build in, in any real application, people are gonna have to build their user-defined functions. It's just, I don't see how any SQL-based system without UDFs is anyway useful. It needs at least the SQL UDFs, if anything, because in the real world you just need more flexibility, and so that has to be easy to do. Like to build. You are doing not mean but standard deviation, or maybe you're doing some. You're calling a machine learning model to give you some estimate, or I don't know. Recently, I was calculating, which is quite interesting use case. If you have GPS coordinations of the car, what is the distance traveled between the points? It's a function. Yeah, it's just mathematical function.
And it's a function that it's one that's easy if you just want to do Pythagoras, and a bit more tasty if you want to consider the curvature of the Earth.
Yes,
right.
Exactly.
Yeah. I was thinking about that recently. We were talking with a friend, like the problem with some of the SQL engines. Maybe you can tell me how you solved this. So the problem with some of the SQL engines is you've got that ceiling where eventually you get kicked out into, say, Java.
Yeah.
And if you've got user-defined functions, that ceiling goes a lot higher, right? There's a lot more you can do staying in SQL. But you always have a problem when you let users run their own functions, but you're trying to provide a cloud service. It's like you can't let the public run arbitrary code, but you need to let the public run arbitrary code. How do you solve that?
Yes. Well, first of all, I would say that the user-defined functions of SQL move the ceiling higher. It's also opened the doors for monstrosities of. I think that when people start to build a business logic in SQL, very quickly it gets very ugly. And I have quite experience with that in the beginning of my career, actually.
Yeah, but I may have committed a few sins myself in my past.
Yeah, I remember the T-SQL times very well, when people were creating 1,000 lines long straight procedures. And this is kind of lead to the same thing. Yes, so to run the customer code, it's a challenge. Now, the way how we have solved it is using a Docker and Kubernetes and set the rules around it accordingly. But yes, you kind of opening the Pandora's door with that. But I don't see the way in limiting the framework. The way how I see it is that people will just deploy dedicated instances of the thing for systems that requires the extra protection from any sort of separated infrastructure.
So don't do language level security, do container level security.
Yes, because I just don't see how a SQL based transformation without UDFs not be anyway useful. Because you're literally working with 5 or 10 or 15 functions that you have at your disposal, and that's just not gonna cut it to me.
Yeah. I think we do sometimes in the streaming world underestimate the business value of just taking this schema and turning it into that schema.
Of course.
But as soon as that becomes day-to-day work, the more interesting work, it's like being given a programming language where you can only use the standard library.
Yeah.
There's a lot of work you can do, but if you can't define your own stuff, very limited.
Yeah. And yes, and also, the standard language libraries are usually much richer than the the Flink SQL is quite rich, full, because the libraries and the engine is very old, but still, it's still limited.
The nice thing about SQL is it's very accessible, and even non-programmers might well know it. But I think that's becoming kind of true of Python too.
Yes. Having said that, we also planning to build a SQL layer on top of our Python library because, it's not that difficult, to be honest, and it has a value. It's opening the door even more for a bigger pool of people. But yes, I think that Python, it's, the Python is the most used language in the world. And there are reasons for that. I think it's probably easier to learn than the others. Although Python wasn't my first language to learn, so I kind of never had the opportunity to learn the Python first. And I think second is the ecosystem. Like right now, if you look at the world right now, all the interesting stuff, all the thing around LLM, all the interesting innovations is somehow happening in a Python ecosystem, and that's, I think, what fueling the user base of the Python.
Yeah, it's the de facto. It's becoming the de facto language for people getting into programming and for data manipulation experts, right?
Yeah, it does. Yeah. And I would argue that if you're starting in the ground zero, is it gonna be SQL that much easier than the Python if you because to me the SQL problem is that lack of autocomplete in most cases. Some databases have autocomplete and that's great, but it's always kind of fiddly. And if you start with the Python right and you get a good content, I don't think it's much more complicated. But then the power you get with it is so much higher.
Yeah. Again, that ceiling is, it's a general purpose programming language, right?
Yeah.
Okay, so are you at all tempted on that logic? You know how to do it. You're looking at making it accessible to more people. Are you at all tempted to say our next target is the JavaScript world or something like that?
We're constantly debating this internally. How we gonna what we're gonna do here? We have focused on one thing because as a company in our stage, we have to focus our resources. And to be fair, because we're not building just the library, we're building the whole cloud platform to help you process streaming data. It's such a challenging engineering task that even with the focus to Python, it's still too big. We will look into more languages later. That's we will do that. But now we're trying to solve the Python.
Okay. And so if I start my Gleam library, you're not going to feel too threatened at this stage.
No, okay. Not with the Gleam. But yeah, there are other languages underserved by streaming tech stack. Like, my old .NET, which I started my career on, it's very underserved. It's exactly the same problem, like in Python. Like there's no difference in the problem. It's just that maybe the Python has more users, but the .NET is super underserved. The client library to Kafka is very suboptimal, I would say.
Right, that's maybe a diplomatic way of putting it. It's surprising because C# is so spiritually connected to Java. You would have thought that it would already have pretty good support.
Yeah, and there will be a something like a Kafka Streams, very well supported by some big company, but it isn't. There's some open source attempt, which I haven't tried. But yeah, it's people are left in a suboptimal place to use Kafka and other technologies in that stack.
Okay, well, so let's just go on to a slightly different topic, which relates to you dividing your attention as a small company, right? You've got a cloud platform, and I'm going to say the user interface for that, for building streaming pipelines, is one of the nicest I've seen. So give me some insights on how we make this whole technology presentable to people in the world. Not just accessible to programmers, but like the art of user interface design for a new area is a tricky one.
Yeah. I think one of the most important UX element that we have done is our pipeline view, which kind of help you to just get your mental thoughts straight in what you're actually building, and what is actually built by others. So like even people that are not programmers, but going to be maybe using this pipeline, maybe they will use the result of the pipeline somehow to integrate it, or they just need to understand what the team is building. With this pipeline view, you can visualize it in your head. Just getting a bunch of services that maybe have some environment variables in them, that's very difficult. I think the second thing we are now trying to kind of internally do is to serve this technology to different personas, because they have very different way how they want to consume the data and how they want to use it to their goals. So you have a software engineer, which probably want to use full power of microservice, full power of local IDE, and full power of the dependency management that provides, versus maybe a Python analyst that using Python that wants to just do a simple analysis on data and just write a couple lines of Python to manipulate data, to do the windows, to do filtering, aggregations, and maybe they are not interested in using the full-fledged programming experience there. So this is where kind of we're thinking on that front.
Okay, is this? As I always think that. You get a data science job and you think you're going to be doing data science. You actually spend 80% of your time cleaning up data. Are you looking into this idea of what's the word? Data mesh, like data catalogs? Like we can easily build something that will do all the cleaning of data and then present that as a user interface, like here are your options for data sources within the company.
Yes. I think that with this approach, first of all, you don't end up having such a unreadable dirty data. That's the number one thing, because you can branch the data as they come into the system and then save them in a nice way. So you kind of moving the responsibility of do something with the data before they saved versus after they saved.
Okay.
Which I think is very powerful, because the natural thinking is, I'm getting this data, let's dump it to S3.
Yeah.
And or similar style of database storage. And then, and then you have this 80% of the time they're trying to do something with it.
Yeah.
Whilst you can actually, still dump it to S3 because there is still, point in that. But then you can build branches and say, okay, there is a bit of time series data. Well, let's save it to Influx. Mm-hmm. And here we have some data for our vector database. And maybe here a metadata for Mongo database or similar style document store could be useful. And then if you enable them to do that, rather than some integration engineer that's actually getting data in, then they can actually leverage it. So that's the number one thing. And in terms of the resources, I think that it's just about getting companies to being in a better game in terms of data, like how you treat your data and where you are in that game. This is just one step. It's not everything. There are more things to improve that, but it's just one step.
Okay, that makes you think of one more thing we haven't really touched on, and it's not a natural fit for the Python world, but data schemas, types. Is that part of the puzzle that you've thought about?
No, it's a very good question, actually. We're going to integrate with schema registry. We haven't yet, and I tell you kind of the reason. Other libraries and other engines are strictly typed, and they strictly require you to get a certain schema in the topic, because the way how they surface the data as objects, and for that you need the types. Now we surface data as data frames, tables with columns, and they don't require such a strong schema, although at a certain point. And there are definitely use cases where schema registry integration makes total sense for validation and for kind of the whole company-wide orchestration of your schemas. But it's not mandatory. So you can still, equally as you would do in Pandas in Jupyter Notebook, you can check, are these columns present in my data, and maybe fill the columns that are missing with something. So, people in Jupyter Notebooks are not used to work with schema registries.
I can believe that.
Yeah,
and so I can believe that most Python programmers are happy with dynamic typing, sure.
Exactly. But the reason why we planning to integrate it is that this is not 100% true. And also, it helps with some, things like data visualization and etc. When you kind of provide some metadata for data that you're sending. But on the other hand, it also bringing a lots of complications in other use cases. So that's why we definitely never gonna make it mandatory. So, imagine you getting data from IoT device that have a different sensors sending in a different frequency.
Yep.
Now, what you're gonna get is, for example, GeForce data 20 times per second and GPS data once per second.
Yeah.
Now, are you gonna send it into topics? That will make your life very hard. So then what you have to do is create a schema that contains both, and then you're just sending unnecessary syntax sugar around, or encoding sugar around. Or you're gonna send messages as you want, and then you have a processing in a pipeline that just join the data when you need it, but not join the data when you don't need it. So you don't need to join data to sync it to your database, but maybe you need to join the data if you need to reference both columns in your processing logic.
Okay, I can see that as a solution. We are gradually going full circle here, but I'm now thinking about error handling. Now, I'm not a Python data frames expert, so correct me if I'm wrong, but I believe when you're dealing with, like, you deal with data, you've got a million rows of data, you calculate something, all the data's there, so it works or it doesn't. Right.
Yeah.
In the streaming world, you can have code tested on a million rows of data, and then the third millionth row turns out that number isn't a number. Sometimes it's a string.
Yeah.
How do you deal with the error handling when you can't process your errors in a batch?
There are two type of use cases which requires a different way of handling these situations. So either you are in a situation where, and that's usually when it's stateless operations, to be honest, but where you rather get data continuously and you rather not stop your processing, and then you probably send the messages that failed to a dead letter queue of some sort, basically a topic which will hold the messages that wasn't processed properly. And the second use case is where actually it's a stateful operation where missing one message could make everything completely incorrect.
Yeah.
And that is, by the way, a default behavior of our library. And it's that the way how it would work is that when you reach to the point where there is something like that there is an exception, the code will stop there, restart the service to the last checkpoint, and try it again. Because maybe, it was some environment factor in it. And if it's not, if it's really just your code, the still processing will stop there until you fix it. Until you deploy a fix in your code, it will be basically stopped at that checkpoint. And it's fine because you have the storage of topic and you have the checkpoint saved and you have your state saved to that checkpoint. So the moment you update your code to fix, maybe you have not expected the date in that form, or maybe you have not expected that this column might be missing, then you can continue your stream processing. And that's this is a second scenario, really.
Okay. Yeah, that makes sense. And is the dead letter queue scenario, is that something I would just handle as ordinary Python code? Try, catch, save it off. Yeah.
Yeah.
Okay.
Yeah. It is like, imagine you have very stateless processing where the fact that one message in 100 has a corrupted schema or corrupted data in it doesn't necessarily mean that 99 messages has to stop working as well. But if you have a problem with, a balance calculation on your bank account, now it's probably better to stop.
Yeah. And that's definitely a domain-specific thing. Like, how important is it to process every single row? Yeah, that's totally makes sense. Okay, so I think it's almost time for me to go and build my Gleam-based competitor. I better go and have a look at Quick Streams first on my local dev container. How do I get started?
So the first thing, you just do a pip install Quick Streams. Which is part of the beauty. And then on our website, we even have a code sample with a public source. So you can literally play with that. And then when you are ready, you can sign up for our cloud and actually start building the pipeline. But yeah, the easiest way is to literally do a pip install Quick Streams and get that code sample from our website. It's doing some windowing, and you can change it to do whatever you want.
Kick the tires on it and see if it's a good fit.
Yeah, exactly.
Yeah, cool. Okay. Okay, great. I will go and do that, and then I'll go and speak to my Gleam expert team. And you'll see me competing with you 2 years from now. Thomas, great to talk to you.
It was great to talk to you as well, and thank you very much for having me. And
pleasure.
Yeah, good luck.
I'll see you the next time you are in London.
Yeah, see you next time.
Cheers. Well, thank you, Thomas. And I'll tell you that I genuinely have started scratching out a Gleam library for this, but it's going to be a very, very long time before it's anything more than my little toy playground. Unless for some reason you want to invest, in which case we're weeks away from launch, provided we can secure the right level of funding. While you're holding your breath and waiting for that library, don't hold your breath. While you're waiting for that library, if you want to kick the tires on Quix, your best bet is probably pip install QUIX-streams, and then check the links in the show notes for documentation. One quick announcement before I go. If you're a regular listener, thank you for joining me regularly. There won't be an episode next week. We'll be back in a fortnight. That gives you a little extra time to like, rate, or share this episode. Please do. Please take a moment. And if you're not a regular listener and you're not already subscribed, do click on subscribe and join me in a fortnight for another Developer Voice. Until then, I've been your host, Chris Jenkins. This has been Developer Voices with Tomáš Neubauer. Thanks for listening.